Right, we are learning about the Boolean operators now. The Boolean operators are operators, excuse me, that combine two or more true and false statements. So it's allowing us to combine two conditions that we have already. Okay, the OR operator is the first one, and it's two symbols, it's two up and down. It's a shift and then backslash. Yeah, I believe it's up there. Okay, it's false only when both values are false. So this is a truth table. You probably are not as familiar with the truth table as we'd like you to be, but basically a truth table goes through every single possibility that you could have with A and B true and falseness. So if A is true, B could be true. But also B could be false. So if A was false, B could be true. But it could also be false. Okay, so this is generally how all truth tables start. They start with the combination of true and false. So this is every possibility for A and B. So the OR statement, remember it says is false only when both values are false. So this is the only place they're false. Every other time it's going to be true. Okay, that's truth table. Yay. All right. What's wrong with me? Okay, so looking at this is an example. So we're combining two conditions. So we have x is equal to 5 and y is greater than 7. So if x is 5, this would be true. Or, and y is greater than 7, so since y is 8, this would also be true. So true or true would definitely output the true. Okay, so now, moving on. If x is 3 and y is 8, that means the first one is false. The second one is true. So everything's true. So as long as there's one true, the whole thing is true. So x is 5. So again, I'm going to just do it over here. So we put 5 in there. Or 6 is greater than 7. That's false. So this would not output, so this would also output true. This one here, x is 3, so that's false. Or false, because y is 6, and that's also false. So this one would not output anything. Okay, so that's how it works. Pretty exciting. Short circuit evaluation, so it's important you understand this. We use this quite extensively. It helps us a lot with math when we have issues with you can't take the square root of a negative number or can't divide by 0, and it eliminates that from happening. So with an OR, if the first statement is true, it will not evaluate the second statement. Okay, so basically you have two statements in an OR. If this one is true, it won't even look at that one because it knows that the whole thing is going to be true. So we'll do a couple examples like that, and I'm sure at some point we're going to show you a few spots where it's very useful. So let's just do another truth table. So this one is the AND. AND is true only when both values are true. So this is the only spot AND is true. All these other spots, excuse me, that's an F, are false. Okay, so that's important for the AND. Love doing that. It's like 3D. All right, so same thing, but we're doing this time with an AND. So if x is 5, y is 8, they're both true. True and true. I can't do these things. True and true is going to output true. So this one here, x is 3, so 3 is not equal to 5. So this one is false. This first one is false. So this is the short circuit I'll talk about with this one. If the first one is false, I don't even have to look at the second one. It doesn't really matter what the second one is. Okay. I mean, we can look at it because we're human and we can do that. So that it would be false and true, but it doesn't matter. This one will not evaluate. So that's what short circuit is all about. It's easier to see with an and, I feel like, for some reason, but I could be wrong. So here, x is 5 for G. I forgot to fix those, sorry. For G, x is 5. Y is 6. So this one is true, so it does have to look at the second one. So it looks at this one is false, so now this one doesn't output anything either. Okay, and then finally we have they're both false, so it doesn't even have to look at both of them. It's not going to evaluate anything. Okay, so with the short circuit evaluation with the and statement, if the first statement, so when it's, because it's doing things from left to right, okay, so it's looking at that first statement, whatever that first statement is here. If it's false in an and statement, it will not even look at the second. It doesn't need to. Okay, order of operation. So when it's doing, it's performing, we do these big conditions with assignments and all that stuff inside them, and less thans and ors and ands and all this stuff. Order of operation, it does operations with one operator or one value. So each one of these only needs one other number or letter or condition or whatever. Then it works its way down. Okay, so it works its way down, does it? Please notice here a couple things. The most important thing that we're doing here, because we did the other one already, is and always comes before or. Comes before or. They're not on the same line. Remember, if they're on the same line, they get evaluated from left to right. So, you know, you understand order of operations. But and or are on two different lines, and has higher precedence. So that one comes first. And remember, assignment does evaluate from right to left. Okay, we did that one already. So let's just do a few of these. So let's use our short circuit evaluation if we can. So this is an or. So that means if the first one is true, the whole thing is true. So x is 0. No, that would be false. So or and, oh, sorry. What's wrong with me? 0 and 0. So these are both false. So the whole thing is false. So 9. 9 is greater than 7. True. I don't even have to look at the whole thing because the first one is true. In an or statement, the whole thing is true. So 10, I put 10 in here. 10 is greater than 7. True. I don't even have to look at the other one. Isn't that exciting? See how that... Anyway. Okay. So and is different. Remember, and says that both of them have to be true for it to be true, but if the first one is false, I don't have to look at the second one. So we put a 0 in here. 0 is greater than 7, that's false. 0 is equal to 9, that's also false. Oh, if it's false, I don't have to look at it. So I didn't have to look at that one. All right, 9 is greater than 7, so that's true. 9 is equal to 9, that's also true. So with an and, this is false. And 10 is greater than 7, that's true. 10 is equal to 9, that's false. So with an and, that is false. Right. Also, I just want to point out here, what I created here is a Boolean variable that's holding the actual condition as an answer. So it's actually asking you what the value of answer is. So the value for answer in these is the actual true or false value that's going to be stored in answer. Okay, 3. What is the difference between these two statements? There is nothing different. Because of order of operations, I don't really need the parentheses here. They aren't really necessary because the or will be evaluated after this and this. And so it does not need, these are the same. Okay, to the computer, they're the same. We all understand that in math, we can write and statements like this instead of like this, these two together, and it's an and. We cannot write it like this. This is bad in Java. And the reason that is as I'm going to tell you right now. So ands combine a true and false statements, and less than or equal signs compare primitive types or doubles or integers, whatever. They compare numbers. So 2 is less than x, so that's going to be either a true or false value. So I'm just going to pretend it's true, and this one is going to also be a true or false value. Done. Okay, these can be compared. This is perfect. But what happens here is it evaluates these two. 2 is less than x, so let's say I give that it turns out to be true. True is less than 12. What? That doesn't even make sense. So it's because the order of operations is making it do one little piece at a time. It can't do multiple things at one time. It can only do one at a time, and it can't compare true and 12. Okay, is the expression it is not the case that x is greater than 10, equivalent to x is less than 10. No, it is not. Okay, it's equivalent to x is less than or equal to 10. So basically this is saying the opposite, or all values that are not greater than 10 are less than or equal to 10. What operator would be evaluated first in this? Well, it's always the innermost parentheses. So the innermost parentheses will go first in this. Okay, what goes next? Doesn't matter. That's not what it asked. So what is the result of this guy? Okay, so take a second and try that. Hopefully I'll pause it here. Okay, this is true. I hope you tried it on your own first so you can see what you did, and hopefully you did it right. Okay, so this is true. So the first thing it does, order of operations, is the not. So if A is true, not A is false. Okay. I'm just going to rewrite this whole thing. So A is true, B is false. Okay, so I'm just rewriting it with the pieces. So what happens next? So what happens next is the and. As I said, and gets done first, so it's going to be false and false, which is of course false. And then it's going to be true or false, which is true. Interesting, right? So just make sure you realize that the and comes first. And gets done before or. All right, have a wonderful day.